I discussed about different advantages of traction system. Okay, so especially for the uh, locomotives and electric multiple units. Okay, so today here you can see other examples of the traction system, like you can see different mills. Okay, paper mill, you know that one's rolling mill or paper mill, then bridge, hoist, cranes. Okay, then see in CPR. So different applications of tractions are also you can see over here. Okay, so these all are the very popular example of the tractions. Okay, so so that's why you need to know about the driving system of the traction, is that's why very significant. Okay, so normally we're using power electronics converters for the driving of the tractions motor. Okay, so that also been discussed later of my slides. Okay, so that's why power electronics converter are very much famous and popular for our current scenario for controlling of the traction motors in some very simple and sophisticated manner. Okay, I think you are able to see different applications of traction motor. Okay, so now what are the most important major classifications of the tractions. Okay, so that you need to know. So here you can see that non-electric tractions, and two types are classifications, you know, that one is called non-electric tractions, another one is electric tractions. Okay, so these all are the very simple things. So non-electric tractions means you are not using the electrical motors. Okay, especially we are using the mechanical arrangement for the controlling of our drives, means traction drives. Okay, so two basic examples are, you know, that steam engine drives. Okay, that initial days is we are using for electric tractions. Motor means railway system. Then IC engine drives. These two are the very popular old, and that these two are the very old concept. Okay, so steam engine drives, you know, that stroke engine. Okay, so steams, that water steam can give you the ultimate thrust for the movement of the traction motor. Movement of the means motor coach, actually railway locomotive, movement of the locomotive. IC engine means it's a stroke engine. So you are using a diesel multiple unit, DMU. That is called a diesel multiple unit, means DMU. Okay, so that's such examples of the IC engine drives. Okay, so and then means internal combustion engine. Then electric tractions are in the pictures. Okay, for the examples of the electric traction is the diesel electric drives. Again, that means both are there. Okay, diesel electric drives means diesel as well as electric, means diesel is used for the generation of the electricity, and that electricity you are implemented for the internal electrifications, means internal loco electrifications, and the traction motor drives. Okay, so gas turbine electric drives. Okay, so again the diesel, next one is the gas turbine. Okay, so same thing, you are using turbine, means you are moving the prime mover. In case of diesel, what happen, you are using that chemical energy to moving the prime mover of the generator. Okay, then you are able to produce the electricity. In gas turbine concept, the turbine is there, so turbine is converting that other energy to the mechanical energy. Okay, so gas turbine means you are using the gaseous form of that air, so that is you represent that is responsible for movement of the prime mover. Prime mover means turbine shaft. Okay, that prime mover is directly coupled with the alternator shaft, so you are able to get the power generations from that concept, and you are able to use that electricity for your traction drives and your internal electrifications. Okay, electrifications. Okay, these two concepts are important. Then what are the most important requirements of the ideal traction system? Okay, so most important features, all of you please note it down, all those comments. No need to note it down, so it's also that video also been available. Okay, so means audio lectures also been available after the class, so you can follow from there also for preparing your class notes. Okay, so all of you should be remember that by this Sunday you have to complete that much I have covered by this month. Okay, so at that case, that ideal traction system, what are the most important features for the ideal traction system? Okay, so first you need to know the that means starting track strip effort would should be the high so as to have the rapid acceleration. Okay, so rapid acceleration means how fast your system take means how fast your system means your traction system means locomotive reach the rated speed. Okay, means how quickly it is achieve that amount of speed. Okay, so that is depends upon your rating of the motor, not like only rating of the motor all the times. Rating of the motor is important issue as well as the other parameters. Okay, means motor rating is changing means the voltage rating, current rating, power rating also has been changed. Okay, as well as the controlling unit. Okay, that controlling unit of the motor is also very important. Okay, so if your controlling unit is not so smart or it is not able to be the up to the mark as per your requirement, means as per your speed requirement, means so when it will be reach to the rated value. Okay, so if it is not there, then it will be quite problematic. So rapid acceleration depends upon your converter. That means converter means power electronics converter is using as a controlling unit. Means in the drives. Okay, now so motor is there, motor is behaves like a load. So the supply of the motor is coming from the supply of the power, means overhead connections. Then in between them, in between power supply and that motor connections, that power will be processed through the power electronics drives. Okay, so that is important. Power processing unit also very important. So how would you manage it so smartly, and what is the controlled ideas you are using for controlling the power electronics converter? For that controlling idea means you should fetch the motor, you should fetch the motor speed. Okay, so what is your rated speed? You may set the rated speed as your means actual speed, means the means maximum speed. Okay, so how fast your actual speed is reached to the reference speed. Okay, that means not actual maximum speed, not is the reference speed. Okay, so how much time is required? So that depends upon your what type of control structure you are using for your drive system. Okay, so that totally depends on your system configurations. Okay, so how sophisticated your system is it? Okay, the wear on the track should be minimum. Okay, then the equipment should be the equipment should be capable of withstanding the large temporary load. Means you know that machines have a means your tractions have a lot of initial inertia. Okay, so that means you know that static inertia means then after starting of that motor, so that's why quite difficult. Basically that's why we are giving more thrust on the traction motor. Okay, so why the traction motor? At zero speed it can overcome large load. That is the basic concept of the traction. So why DC series motor? Basically in DC series motor at no load it having huge speed. Okay, that's why in laboratory experiment you should not run the DC series motor without having load. So initially you should add some load, then you can run it. Okay, basically if you try to remember the speed torque characteristics, so that will be like that rectangular hyperbolic in nature. Okay, more or less, but power is rectangular hyperbolic nature. But if you see it's like that at nearby zero speed it having huge torque. Okay, so increasing of the speed means torque is reducing. That's why we are giving more thrust on that initially DC series motor. But right now that vector control is coming, so induction motor can be controlled in the form of vector control. Means if you I think the generalized studies of motor means machines. Some of the portion is you have already gone through, or maybe you are going to be reading this semester. I think so. In machine 2, I think it has been covered already. Okay, some of the portion. So you know that we are converting that entire concept in the DQ model. Okay, means three phase to two phase configuration. Then we are using such type of concepts. Okay, so it's look like that in three phase to two q means again DQ model. You know that is called quadrature axis. Okay, then D axis, like that your same concept of your DC machines. Okay, DC motor configuration. So you know sophistically we are using such type of motor, means induction motor in the traction drives. Okay, as per our configurations. Okay, so in the required arrangement we should design the control architectures, okay, for our traction purpose. Okay, so what kinds of concept we are going to be opt. Okay, then speed control should be very easy. So speed control means that means it depends upon your control strategy. So which control strategy you are using, basically by the tacho generator. Normally what happen in the lab, in the laboratory, we are fetching or we are collecting or sensing the basic concept. The terminology is sensing the speed by using tacho generator. Sometimes we are also decoder. Okay, so optical decoders. Okay, so different process we are maintaining, but normally we are using tacho generator. Tacho generator is a transducer. Example of a transducer means that convert that tacho generator is converting the speed in the equivalent voltage value. Okay, so that's why it is an example of a transducer. So tacho generator, what happened, we are sensing the speed, then are converting in the voltage. So in the differential amplifier we are giving, we are comparing, we are comparing the actual speed and the rated speed. So rated speed, your actual speed now in the after tacho generator now in the form of voltage. So definitely your reference speed, you should put the equivalent voltage of your reference speed. Okay, then we are going to be compare the getting the values of error. Okay, so then the error will be passing through the controller. Okay, then controller will give you some response. Then we are comparing with the repeating value or repeating sequence to get the PWM. So that PWM will be fed through the passing through the driver circuit. Then you know that is control of your power electronics converter. Okay, that's a basic concept. Okay, so speed control strategy totally depends upon which type of control strategy you are using. So it depends upon your control strategy. So how fast motor will reach to the rated value of speed. Okay, then pollution free, definitely in electrical motor. If you are using the electrical motor, so there is no such any emissions of the greenhouse gases, so you can say like that it is pollution free. Okay, then low initial and maintenance cost. Okay, so comparatively mechanical structure, you know that there is a huge capital cost. Means you have to purchase it, then you have to maintain. I am requesting most of all the students, please mute your microphone. Okay, some of your microphone is not muted. Please mute your microphone. So after completing my session, definitely I will ask you. I'm requesting you for the discussion. Okay, if you have any doubt, you can ask me that time. Okay, right now you should mute your microphone. Otherwise, I am facing some noise from your side. Okay. Thank you. So pollution-free concept means that I have told. So low maintenance and low initial and mechanical maintenance cost. Basically, for the mechanical arrangement, you have to give, put more investment on it. Okay. The locomotive should be self-contained and able to run on any route. Okay, so that's why we are using that locomotive. Okay, so able to run any route means if it is diesel electric locomotive, so anyhow there is no reflections of that, means no need for overhead line for all the cases, so it can run anywhere if there is a meter gauge. Okay, so if there is a railway track. Okay, then merits of the electric tractions. Okay, that's correct. Then merits of the electric tractions means you know that initially that advantages of that ideal traction. Now what are the important merits? Means high starting torque. Okay, we are using traction motor, so inherently it having high starting torque. Okay, first thing. Then second thing is that less maintenance cost. Electric traction means less maintenance cost. Cheapest method of the traction means you are using that control method, that electrical control method. Okay, so controlling structure is related to the electrical engineering, so it having the cheapest method of traction. Okay, then rapid accelerations and the braking. Okay, so rapid acceleration and braking means you know that which type of braking we are using. Okay, so how what are the methods of the accelerations. Okay, so rapid acceleration means how fast it will reach the steady state value. Okay, then braking method, all are important. Then so less vibrations. Okay, so vibration should be less. Okay, means mechanical means there is a lot of noise, corrosions. Okay, lot of effects. But in case of electrical, so vibration is inherently less. Basically why it is less, we are trying to maintain the supply in the sinusoidal. Okay, means we are always trying to omit the harmonics. Okay, every time. So for omitting the harmonics means we are always try to incorporate that fundamental signal. Okay, so from the fundamental signal means we are giving more thrust on sinusoidal signal. So if the sinusoidal signal is there, so definitely there is options for the less vibrations. Okay, so there is the chances of the harmonics will be less. Okay, so we are all the time we are using some of the arrangement for mitigating the harmonics. That is the basic reason. So the vibration due to harmonics, it will be reduced. Then free from the smoke and flue gases, hence used for underground and tubular railways. Okay, so smoke-free applications, that was pollution, less pollution, that I am telling already. I have discussed less smoke and flue gas free applications. Okay, it is free from that. So underground and tubular railways. So tubular railway. So you know that we are using metro rail, that is underground concept. Okay, and that you know that is also look like a tube. Okay, so in UK based, that is tube, you know that one. So that machines are underground machines, they can means make that line. Okay, that all the place plate are look like a road, means all the plates, concrete plates are like a pipe. Okay, that's why it's look like a tube. That's why it is called tubular railway. Okay, in metro rail we are normally in Indian convention. If you go different cities are there, that metro rails are right now running in different cities, but their configuration is different as per the city basis. In Calcutta they are using DC 750-volt DC in the metro rail. Okay, but in case of Delhi metro, if you go there, so you know that the overhead line is 25 kV AC. Okay, but again they need to convert it DC, then they are using. Okay, so as per the city basis, the configuration is changed. Basically in Calcutta metro, means Kolkata metro, it was very old. Okay, so around 85, 83 maybe there. Okay, so it was very old, that's why the total convention is based on DC. Right now all the newly established metro lines, that basically depends upon your AC configurations. Okay, so demerits, definitely if there is a advantage, the disadvantage also be there. Okay, what are the disadvantages? So high capital cost. Okay, the capital cost means initial investment is high. Okay, so you have to acquire the land, you have to put the railway track, then one different PSUs are there, like Vale is providing you the machines, then TWL means or Chittaranjan, they are providing you that bogies, means different companies are there for providing you that railway bogies. Then track will be developed by the sale. Okay, so other different sub unit and means different companies are there. Okay, so that is associated with your Indian Railway. Okay, so that's why a lot of investments are there, so capital cost is too high. But if you consider in the long run, the longevity of one complete train, its minimum around, it is continuously, it may work around 10 to 12 years, okay, with minimal maintenance. Okay, after it having some cycle, when if you do your training in workshop, you can understand that railway, that means all the bogies, coaches are coming, it having some warranty period. Okay, means it having some of the maybe run around 20 years, 15 years. Okay, right now that time is less, 5 years to 10 years within, but after continuous they are maintaining. Okay, so maintaining means their machines totally they are overhauling, means if the machines are there, so they are totally remove all the conductors, everything, then they are rewinding it. Okay, but minimal maintenance, all that every day it will be performed. Okay, minimal maintenance, that means where the EMUs or loco coach are, means that yard. Okay, loco yard or EMU yard. Okay, so when the resting time is required, still it is continuous duty operation, some of the resting times is required. And that in local train it is intermittent duty, means sometimes it is on, again it is off, sometimes on, again it is on, so very short duration of your off time, but on time is high. Okay, so intermittent duty, different options are there. So maintenance is very maintenance cost is high, as well as you have to maintain everything. Then problem in the supply failure, so definitely if you totally depends upon your supply, basically we have to right now the concept is that we are using that electric, we are using that EMU, electric multiple unit or locomotive. Okay, electric locomotive only, so we have to depends upon that overhead line. So any means any unwanted situations, any unwanted situations may occur. Okay, that may cause for disconnect of that supply line, means suddenly in the storm. Okay, so one bunch of means single tree branch is coming and just throw on the high tension line, then what happen, then it will be damaged, so means suddenly LG fault will be there, so there will be no light, so relay will be tripped automatically. So if the problem in the supply line, so it will be hampered. Okay, communication will be hampered. Then electrically operated vehicles have to move on guided track only. Okay, electrically operated on the guided track. Okay, so additional equipment is required for achieving the electric braking and the control. Okay, that mechanical braking also be there. In braking, that electrical braking, then mechanical braking, and the control means motor control. Okay, so different systems of the tractions. Okay, what are the most conventional systems from very initial days to right now? Okay, so what are the very initial concept is direct steam engine drive. Okay, that one. Then direct IC engine drive. Okay, steam engine means main thrust area coming from the steam. Direct IC engine means your fossil fuels you are using. Then steam electric drive. Okay, then steam is using for generation of the electricity, like your thermal power plant. Okay, then that electricity you are using for your traction motor. Okay, then next concept is that in direct IC engine means it is stroke. Okay, stroke engine. Okay, directly that mechanical stroke is coming from that combustions, internal combustions. Okay, that stroke is used to drive the shaft of the wheel. Then IC engine electric drive. IC engine electric drive means internal combustion engine. You are using that fossil fuel. Okay, you are using the fossil fuel, but after combustions you are getting some of the mechanical energy. Okay, that mechanical energy is used to as a prime mover of the electrical generator. Okay, so that stroke is coming, that stroke is used like a prime mover. Okay, that mechanical, that is in mechanical inputs from the IC engine. Okay, and through the generator means alternator, that mechanical energy is converted to the electrical energy, then you are using motor. Okay, so directly that motor, shaft, motor, generator, all are in the maybe same shaft or maybe different shaft. Okay, so then what happened, you are getting the connections from the generator to the motor is getting the connected with the generator, and it can convert again that electrical energy to mechanical energy, means driving of the pinion gear joint, means wheel. Okay, traction wheel. Then petrol electric tractions. Okay, then same thing, means I see in like the petrol you are using for generations of your electricity. Okay, then battery electric drives, that is very important right now. A lot of work is going on battery electric drive, and finally electric drives. So battery electric drive means your total drive is coming from the battery energy. So if you ride in Troy train, okay, you know that different organizations are there in different cities like Nicobar. Okay, the Nicobar, different parks are there, so where the basic energy is the battery. Okay, so that is also electric drives, means multiple coaches are there. It's a joyride, maybe it's a joyride, but it's a battery driven car. Okay, so sometimes that concept also using as a good carrier in airport, in port. Okay, in any of the organizations. Okay, so that is totally depends upon your battery. So if that battery will be regularly charged. Okay, with the sometimes you are also swapping the battery. Okay, as per your availability of the technology. Then final one is the electric drive that we discussed, giving the more trust on it. Okay, like you know that electric locomotive, electric multiple unit. Okay, so currently we are using these two concept. Okay, these two are the very important and popular concept: battery electric drive and electric, only electric drives. Okay, so that is regularly used concept, that electric drives. Okay, then you know that on engine diagram is there, that is IC engine for electric drive. So IC means internal combustion will be there, that is demonstrated. Okay, that engine is now very few engines are still there. Okay, so if you go for the any of the FCI go down, okay, Food Corporation India go down, still you can see such type of engine. So in Food Corporation go down, what happened there, the rakes are there, the goods carrier trains are there for grains are moving here and there. No? So in that case, the small engines are still till now still there. Okay, they are using the diesel as a generations. Okay, then electric generation. Sometimes that diesel energy also using as a stroke. The speed is not too high. Okay, but still it is, if it is there, if it is in the system, still some FCI or Indian Rail are using for. If you see that sometimes what happen, that if you go any terminal railway station like your Mumbai Central. Okay, like your Delhi, in Delhi two big railway stations are there, New Delhi as well as Old Delhi. Okay, if you go for any big terminals, okay, where the rails are, and then Howrah, okay, or Howrah division. So normally what happen, the trains are moving for that source station. Okay, so if you see sometimes some of the locos are there, they are pulling the train in the platform. Okay, that after that what happened, the other, that means that loco will be disconnected with your main coach. Okay, still the engine is there, still the main engine is connected with your train, but it is coming from here to platform. One loco is all the time carrying that train. So normally you can see that is diesel engine. Okay, so diesel engine. Okay, so that is, if it is there in the system, so they are all the time reuse that system. Okay, so otherwise if you design the new one, so the cost will be high. So that's why already existing system should be working. Okay, the concept is like that. Okay, then supply system of the electric traction, that just 5 minutes back I am talking about the traction system. What are the traction system? What are the traction system we are using? Okay, so in case of DC, in case of DC systems are there, then AC systems are there. Okay, So all the cases it is important. Then if AC is there, normally we are using single phase AC. Then three phase, in India I don't think that three phase AC is is there in the overhead connection, but we are using three phase motor. Okay, we are using three phase motor inside as a traction motor. If you are using induction motor, so we are using three phase motor. Okay, then composite system. Okay, single phase AC to DC, then single phase to three phase. Okay, so like that your normally EMU, it is taking the EMU on the loco, it is collecting that AC. Okay, it is collecting the AC, means overhead 25 kV AC is there, then it will be reduced. There is a transformer inside of that motor coach. So transformer convert that AC voltage to sorry, say 25 kV to some voltages are there, like it is nearer to the 750 volt. Okay, 750 volt in AC. Then again power electronics drives are there, power electronics converters are there to convert that single phase AC to DC. That DC is also used for charging of the battery. Okay, that DC initially what happened, that DC you are getting, it is a ripple DC. Okay, you know that if you study minutely just below of your locomotive, so one box is there that is written like a SR box. Okay, means smoothing reactor box. Smoothing reactor box means it is filter out that pulse DC to continuous DC. Okay, then the continuous DC is coming and it is feed to the that continuous DC is directly feed to the traction drive. If it is DC motor, so directly you feed that one to the traction drive. Another thing is that some portion of the DC is used to the charging purpose of the battery. Okay, that battery means the converter is there inside, means in between the DC and the battery, it is called bidirectional converter, bidirectional power electronics converter. That bidirectional power electronics converter can convert, okay, from sometimes battery is charging, means it may be work as a buck mode. Okay, and sometimes battery is discharging, then it's work like a boost mode. So it is example of a buck boost bidirectional converter. Okay, bidirectional converter topology is normally it's a buck boost type topology. Then that energy that is fed to the DC machine, means traction machine, that directly coming to that. Okay, some in between some controls are there. That controls is connected in the driver. Okay, locomotive driver, they can control that one, so they can change the tap. Okay, tap changers are there. Okay, so that transformer is used, na, that changing of the auto transformer normally you are using. So due to the changing of the tap of the auto transformer, the output voltage of the motor is changing. Okay, so motor speed also will change. Okay, sometimes what happen for the field control, that means controlling if you want to the speed more than base speed, means rated speed, so you have to go for that field control concept. So in field control concept, what happened, in field control concept, you can change the current passing through the field. Okay, means it's a DC series motor, so field and armature both will be in series. So one switches, some of the switches are there. Okay, that bypassing switch of the, not like field coil, some additional resistance are already series with your system. Basically for the dynamic braking you are using that resistor. So some bypassing connectors are there. So if that connectors are off, so series current, that means the motor current will flow through that path with the additional resistance path. So motor current is less, means field value will be, means flux value will be less, so you can go beyond the rated speed. Okay, so again you just need to come as the rated speed. So what happened, then you have to connect the bypass switch of that additional resistance. Okay, just turn on the bypass switch, means it will bypassing, that bypass switch means short circuited, means that it will be bypassing that additional resistance. Okay, so it will come to the base speed. Okay, that's the concept basically. Okay, so composite system also very sometimes also very, means initially it was composite system like 10 years back. Okay, that was composite system, AC DC both of the convention right there. Right now maybe it is changed to the only DC system, single phase DC system. So again, it is single phase AC. Okay, sometimes we are using three phase motor. So how it will be converted? So initially we are using Arno converter. Okay, Arno converter is an example of machines. Okay, special type of machine that can convert single phase to three phase configuration. Now we are using different drives, cycloconverter drives, inverter drives also be there. Inverter drives means single phase, it may be DC, you can use that inverter drive. So from DC to you can convert it directly three phase AC. Then you are using filter. So using the filter means you will get the sinusoidal value, and that sinusoidal is fed to the your induction motor, and that can run. If induction motor is moving, means tractions is going on, so there will be no problem. Okay, so but in case of AC DC configurations are there, so you are using DC AC configurations are there, means you are using inverter. If there is AC configuration, so you can use cycloconverter drives. Why cycloconverter drives? Basically, inverter and cycloconverter, the basic advantages is that you can change the frequency. But in case of AC voltage controller, you can also use AC voltage controller, three phase AC voltage controller also been available, but you cannot change the frequency. But in VYF control, voltage and frequency both should be changed by within a tolerable limits, means high value. Okay, that's why it is important that frequency control. So we know that's why normally we are not using that AC voltage, means only AC voltage controller that can only change the magnitude of the AC output. AC input is AC, also the output is variable AC. But in cycloconverter, input is also AC, output is also AC, but we can change the voltage magnitude as well as frequency magnitude. In case of inverter, input is DC, output is AC, but we can change the frequency of that output AC. So that's the basic concept we can follow for our drives for the electric traction. Okay, so supply system is important. Then speed time curve for the train movement. So for the speed times examinations, okay, for the especially I have one lecture. Okay, I have prepared one PPT, basically that speed time curve of the train movement. So that PPT will be discussed after completion of that enter slides. Then we can discuss it. Okay, so you can understand. So we can understand the basic concept. So acceleration time. Okay, so how much accelerations are required? So acceleration time, then constant acceleration. Okay, so speed curve running. Okay, so that details study will be there later classes. Okay, so free run or constant speed period. Okay, coasting period. Coasting period means free running. After free running, the coasting period is there. Means in coasting period you are preparing for retardations. Means regenerative braking that you can implement it on that. The starting of the regenerative braking that you can process for it. So that is coasting period, means reducing the voltage level of that motor. So gradually the speed is lessing. Then you can go for retardation. So all the features may be observed, means acceleration means constant acceleration, then speed curve running. So then free run or the constant speed period run, then coasting period, then retardation or the braking period. All the concept will be observed in the main line transportation only, not for the suburban and urban. Okay, so suburban and urban, some of the features are not there. Why not there? Due to the time constraint. Okay, if there is a time constraint, so all the features not been possible. Okay, within the 5 kilometer. Okay, in urban suburban cases that 5 kilometer and suburban maybe more than 10 kilometer. There is maybe possible, but in urban transportation, in city transportation, it is not possible to accommodate all those features like coasting period. There is no coasting period. Okay, that acceleration, then retardation direct. Okay, so coasting period is not there. Free running portion also be not there sometimes. Okay, so that is vary as per the speed time, depends upon speed time curve and the applications of your electric locomotives. Okay, which purpose you are going to be use that locomotive. Okay, so if all those accommodated within very simplified time, so again the losses will be very high. So if you go for that comparative study, so it is observed that all the features is not required for the very short duration of travel. Okay, so typical speed time curves for the different services. Okay, what are the most important services that I am telling you? Urban or city service that I am telling you na just before. Urban city service, that kilometer in between two adjacent station, railway station is maybe 5 to 10 kilometer, maximum 5 to 10 kilometer. Okay, within 10 kilometer. Okay, so normally it is maintained 5 kilometer. Okay, suburban service, it is more than 10 kilometer but less than 15 kilometer. Okay, so like where the memos are normally moving, then mainline service, so it is more than 150 kilometer. Okay, so sometimes we are traveling the train to Raukela, so you can see that one station is Chakradarpur, then Raukela, so distance between two stations is 150 kilometer, near about more than 100 kilometer, not 150 kilometer, more than 100 kilometer. Somehow Raukela to Jharsuguda, so the distance is 100 kilometer, 110 kilometer, like that. But if you go for that, if that same train is running in midnight, means when normally daytime the number of stations is more, but in night time the number of stations are less. In that case, one train may run, means in mainline, near about 300 kilometers, like Nagpur, then next station maybe the distance is more than 200 kilometers, sometimes 300 kilometers. Okay, continuously 60 kilometer per hour. Normally the train is running, the super fast normal trains are running 60 kilometer per hour. So if you 300 kilometers means 5 6 30 no? So around 5 hours continuously running. But if it is free running, okay, in that case, if the distance is 300 kilometer, so in that case it can run nearer to the 100 kilometers. Normally Rajdhani Express, they are traveling in 5 years back also, their speed was 120 to 130 kilometer. Okay, Rajdhani Express speed. Right now it is 160 kilometer per hour. But that train normally average speed running is 60 kilometer per hour. But at peak time, means in night time, okay, when that in between two stations are a long route, means 300 kilometer, they can run up to 100 kilometer, 100 to 110 kilometer. Okay, so that can be achieved. Okay, so due to the time constant, so 300 kilometer they can travel within 3 hours, like that way. Okay, so mainline service, I am telling about all those things related to the mainline service. Then type of speed of the traction, that I am telling you, means crest speed means peak speed, maximum speed, how can it ever set, that I am telling you 110 kilometers for the normal, 110 kilometer per hour for the normal locomotive in mainline service. Okay, but same speed it is available in urban suburban, that is maximum 50 kilometer, maximum 50 kilometer. Okay, but average speed, okay, if the line is very if the length of the service, means as per the service, the speed means crest speed or peak speed will be different. Okay, then average speed, normally how much value it is maintained, average maintained, maybe if it is 50 kilometer for normal city service, so maybe to 30 kilometer or 25 kilometer is maintained. Then schedule speed, so how much scheduled is there, so it may be more than base speed. Okay, so more than average speed and below the peak speed, so it look like that as per the applications of your locomotive. So where you are using it, so depends upon your application, the speed range also will change. Okay, so factor affecting the energy consumptions. Okay, which are the most important factor, so that is used for energy consumptions. Okay, so that is your distance between the two stops. Okay, so if the distance between two stop is less, then what happen, if you are using, if you try to perform all the steps like initially acceleration, then constant speed, then coasting, then retardation, then stop. Okay, so if you try to implement all those factors, so what happen, for changing definitely that configuration of that switches will be changed. Okay, when speed term means motor speed is changing. Okay, so again, if all those things happened in the against of your moment of inertia, okay, so definitely unnecessary losses will be high. But in case of free running conditions, means if it is urban, if it is mainline transportations, then what happen? Then it's a huge line. Okay, it having inertia, that running inertia will be more in that case. So if you try to make it stop the train, if you try to make the train stop, so you have to maintain all the standard procedure. So first free running is there, after that you have to go for coasting, means try to regenerative braking in coasting period. Okay, means reducing the voltage level. Okay, then some of the regenerations will be there, so additional voltage will feedback to the line. Okay, then you can go for the retardation, again voltage will be less, like that then you can go for the dynamic braking, then finally it can be stopped. So because of that, it totally depends upon your inertia. Okay, so how much inertia it have in current positions. Okay, so that factors is create, that means heat energy loss. Okay, define factors. That's why you have to make it very optimum way, you have to handle it very optimum way. Means conventional way, there is some already predefined guideline. Okay, means the train or the loco drivers have those kinds of guideline, they are following that rules. Okay, then train resistance, that initially train having the huge resistance now, so that is called friction, static friction. Okay, so you have to overcome in initial resistance. Next one, the acceleration and the retardation. So acceleration time and the retardation times. Okay, basically it's not like that. So if you try to accelerate gradually, so if the slope is less, means moderately, like tan 45 degree, means m value is 1 nearer, so it will be very moderate way, gradually increasing. Okay, gradually increasing, both having the same factor. Okay, so acceleration will be better, but time will be more time, it will take more time. But if you increase the value of slope, okay, means theta angle is more, then what happen? So that acceleration means it will reach the steady state value. Okay, if m is 1, so it will be take some time to reach the steady state, means base value. Okay, rated value. If m is if it is more than, m is 1 means angle is 45 degree. If the angle is more than 45 degree, then what happen? The problem is that it will take additional time. Okay, sorry, it will take first, and that value, that steady state value, means rated value. Okay, so acceleration will be more. Okay, acceleration will be more means more energy you have to give to the changing of that inertia of the motor. Okay, more voltage you have to put, sometimes you have to put, sometimes reduce that current, means changing of the flux. Okay, like that way. So it depends that how much factors, means how much energy will be dissipated, it will be depends upon your acceleration and retardation time. Then gradient, that I am telling you na, gradient, how much values are there. Okay, if m is 1, it will be different, if m is 0.9, it will be different. So changing of the gradients also making sense. Okay, also makes sense. Basically I am telling you just now. Okay, so how the gradient has changing with the factor. Okay, so then the train equipments, that also being related to the train resistance, means if it is well equipped. Okay, all the lot of fans are there, lot of lights are there, it also put you some additional weight. Okay, so the decorations of the train, if there is a sofa set in the train, definitely the weight will be more. Okay, so train equipments also make some sense for changing the factor affecting the energy consumption. If the factor is more, means more energy will be dissipated, more energy consumption is required. Then tractions motor. Okay, in traction motor, what type of motor we are normally using? DC series motor we are using, basically it is well known traction motor. Then AC series motor, sometimes we are also using AC series motor. 3-phase induction motor. Okay, 3-phase induction, AC series motor for the single phase operation. Okay, 3-phase induction motor also being used. Okay, for that V by F control I am telling you. So now the electric vehicles are there. In that case we are using BLDC motor. Okay, it's a synchronous motor. Okay, BLDC motor, it's an AC synchronous motor, brushless DC motor. Sometimes we are also using means reluctance motor, switch reluctance motor. Okay, means the robotics, means step changing of the motor, and step changing drives, means robotics, the wheel of the robotics, it normally depends upon your switch. It is stepper motor. Okay, Switch inductance motor having some of the specific applications, but permanent magnet motor also be there. That is also using that electric vehicle, means city ride vehicle. Okay, BLDC and that permanent magnet motor, that also been used in our normal electric vehicle city ride applications. Okay, so depends upon your applications, traction motor will differ, and the technology generations as per the motors is changing with the generation changes by the traction motors. Okay, so all are most important. Okay, so I think today I just complete my class up to that portions. Okay, so next day I will start another. I'll discuss about another features. Okay, so if you have any kinds of confusion, please ask me so I can give you. I can clear your confusion. If you have any kinds of doubts, okay, so you can ask me. So after that I can take your attendance. If you have any doubt, you can also text me. Text me means text in the conversation in chat box. Okay, so no message is coming from your side. I hope there is no confusion from your end. Okay, so we can conclude my today's lecture session. Okay, thank you.